So, yes, Quentin. Yes, but next time, let's go sometime not during the lesson. Okay? All right. So today we're just looking at more compound events. We are not doing anything new today. So yes, this can be on the quiz tomorrow because it's not new material. Okay? So let's take a look. Nina is buying a new pet fish. At the pet store, the fish tank has an equal number of two kinds of fish, tetras and guppies. Each kind of fish comes in 4 different colors, yellow, orange, blue, and silver. There's an equal number of each color of fish in the tank. That's important because, it could be that there were a lot of silver but not very many blues or something like that. So it's important that you read those carefully. So if Nina scoops out a fish at random, what is the probability she will scoop out a silver tetra? Make a probability table to justify your answer. All right, so let's make a table for this. So when you're making the table, it's your choice as to which way you want to do it. You can do the type of fish up here and then all the colors, or the type of fish in the column and all the colors over here. Does someone have a preference? Yes.
I do the types on the top.
The types on the top? Okay, I'll do that. If you did it the other way, it's not wrong. So tetras and guppies, and then we've got yellow, orange, blue, and silver. I'll cheat and make my lines nice and straight. So then this would be a yellow tetra, an orange tetra, a blue tetra, and a silver tetra. And this would be a yellow guppy, an orange guppy, a blue guppy, and a silver guppy. Yes.
Does it matter if we put the T in front of the Y?
No, it really doesn't. And that's actually, I was going to say that. That's one of those things that English is different than a lot of other languages. Like in Spanish, for example, if you were going to say the red car, the color comes first, then car comes second, right? In English, you do the color first, then the object, which when you think about it is kind of weird. It's like, wouldn't you want to tell people what the object it was before you told them what color it was? But that's the way English typically does things. So yeah, it doesn't make any difference. So how many different possibilities do we have? How many do we have? Everybody. There's 8 possibilities. How many of those possibilities are silver tetras? 1. So the probability that it is a silver tetra or a tetra that is silver is 1 out of 8. And this goes back to what Sam and I were talking about on the homework. There are 2 types and 4 colors. 2 times 4 is 8. There's a total of 8 different possibilities.
Yeah, that's what I would do in the first one. Like 1/2 by 1/4.
Okay. Yes.
For like you saying like 2 times 4 would take 8, and then you would have to find like how many silver tetras there is. So you just put it 1/8, and then for the homework one, since it's like asking for a whole number of like how many outfits, like
Oh, it was asking how many possibilities. Here, there are 8 possibilities,
I mean it's
right? The probability of getting a silver tetra is 1 out of 8. Okay? And the other thing, and this is what Sam was saying, is that what's the probability of getting a tetra?
1/2.
Is a half. The probability of getting something that is silver is 1/4. So the probability of getting a silver tetra, you can just multiply the 1/2 times the 1/4, and you get 1/8. Okay? All right. So what's the probability that Nina scoops out a tetra at random? So the probability of getting a tetra. Everybody, what's that? 1/2. What's the probability that she gets a silverfish? 1/4. How are these quantities related to your answer from part A? I should have read ahead. Well, 1/2 times 1/4 is 1/8. So another way to do a probability table is to write the probabilities for each event in the headings and then use them to find the probability of each compound event. Now, honestly, for a problem like this, I would never do it because each probability for the colors is equal. But if the probabilities were different, this is a great way to do this. So let me just show you. Probability for yellow is 1 out of 4. Probability of orange is 1 out of 4. Probability of blue is 1/4. Probability of silver is also 1/4. The probability of getting a guppy is 1/2. And then to get the probabilities for the compound events, you can just multiply those together. So like here, the probability of an orange tetra, it's 1/8 because 1/4 times 1/2 is 1/8. The probability of getting a blue tetra, 1/4 times 1/2 is 1/8. The probability of getting a silver tetra is 1/4 times 1/2 is 1/8. The probability of getting a yellow guppy, 1/4 times 1/2 is 1/8. They're all going to be 1/8. Probability of an orange guppy, I don't think guppies actually come in all these colors, but we'll pretend. The probability of getting a blue guppy, I'm pretty sure guppies don't come in blue. And the probability of a silver guppy is also 1/8. Okay, any questions about that? All right, let's go on to the back then. All right, so here is the rule that we talked about on the front. The probability that two independent events will occur is the product. What does it mean when you say the product? Multiply. Of the probabilities of the two individual events. That is, the probability that A and B both happen, if they're independent, is the probability that A happens times the probability that B happens. So let's take a look at this example. Fred decided to try and use the rule for compound independent events for events that were not equally likely. Okay. So he put 3 cubes into a bag, 2 blue cubes and 1 yellow cube. He pulled 1 cube out, put it back in the bag, and then he drew another. Let's make a probability tree to show all the possible combinations he could draw. So on his first draw, there are 3 blocks or cubes. So from the initial, there are 3 different possibilities. There were 2 blues and a yellow, so it could be a blue, or the second blue, or it could be a yellow. And then he replaced it, and we draw again. So from each of those, there are 3 possibilities. The first blue cube, the second blue cube, or the yellow cube. And that happens at each of these ends. And Rory and I were talking about this. It just, these get messy. Try to make it as much as possible to where these all end in a line, right? I'm not, judging your super neatness on this, but you want it as much as possible to end in a line. So, how many different combinations are there? Well, there's 3 plus 3 is 6 plus 3 is 9. There are 9 combinations. All right, so what's the probability of drawing 2 blue blocks? Well, what's the probability that he draws a blue block?
1/3.
How many blue blocks are there?
2, so there's 2 sixes. Oh, sorry, 2/3.
2/3. Okay. So the probability of drawing a blue and then another blue should be 2/3 times 2/3, which is 4/9. Let's take a look at that on the tree. So this was blue, right? That was blue. This is blue. And that end is blue. How many blues do we have? 4 out of 9 different combinations. Let me show you how you could make a probability table for this. So, just like we did over here, we're going to give the probabilities for each of the possibilities. So on our first draw, what's the probability that you get a blue? 2/3. And what's the probability that you get a yellow? 1/3. And on the second draw, the probability of getting a blue is still 2/3. And the probability of getting a yellow is 1/3. So the probability of getting a blue and a blue, if we multiply 2/3 times 2/3, that's 4/9. The probability of drawing first a yellow and then a blue is 1/3 times 2/3 is 2/9. Probability of drawing a blue then a yellow is 2/3 times 1/3. That's also 2/9. And the probability of drawing the yellow both times is 1/3 times 1/3, which is 1/9. So again, how could you arrive at your answer to part B without a tree or a table? That's right here. We just take the probability of drawing a blue the first time times the probability of drawing a blue the second time. And that gives you the probability of getting a blue and then a blue. All right, let's look at this last example. The pet store sells a lot of pet food. On a slow day at the pet store, 3 people buy cat food, 2 people buy dog food, and 1 person buys food for a snake. If half the customers pay with cash and the other half pay with a credit card, what's the probability that a customer buying pet food will buy dog food with cash? Okay, so what's the probability that they buy dog food?
6.
So why is it 2?
Because there are 2 people who buy dog food.
Right, there's 2 people that buy dog food, and why is it over 6?
Because there's 6 total people.
Right, there's 6 total people. So that's 1/3. What's the probability that they're going to pay cash?
1/2.
Because it tells you half of the customers pay with cash and half pay with a credit card. So the probability that they buy dog food and that they pay cash, we'll just multiply those 2 together. It's 1/3 times 1/2, which is 1/6. I'm sorry. Yeah, there's 1/6. Any questions about that? Okay,